right, this is a target 4D, compositions of translations target. So this is where we combine compositions. Okay, so let me grab a pen and we'll get started. Color though. Okay, so this says we're given some points, B, A, and T, and we have to graph it, and then we have to do a glide reflection. So a glide reflection consists of a translation and then a reflection. So first of all, it wants us to list the points. So they're already listed here, but I guess I'm going to move them down here so it'll make it easier to manipulate them. -2, -3 for B, A is 0, -1, and T is 3, -1. And let's go ahead and plot them. So B is -2, -3. And A is 0, -1. And T is 3, -1. So this looks like B, A, T. So this is triangle BAT. Okay, now the first thing we have to do is the translation. So this X is by itself, so that means we don't move left or right at all. But remember, this Y plus 2 means move up 2. So I'm going to take all of these points and I'm going to move them up 2. I'm going to get a new color and I'm going to move them up 2. So if I move these up 2, I get T prime right here, A prime right here, and B prime right here. And then I'm going to, connect the dots. And let me erase that extra little line I had there. Okay, so now, let me get my pen. We have to get the new points. So remember, we can use point manipulation to move these as well as counting. So if I just plug in here Y plus 2, that would be -3 plus 2, so that would be -1. And the x-coordinate doesn't change, it stays the same, so -2. And here, if I replace y with -1, I get -1 plus 2, which is 1. And that didn't change, that's still 0. And here the 3 is not going to change, but I'm going to replace, again, the y with -1, and I get -1 plus 2, which is 1. So let's see if these are right. B prime should be the point -2, -1, and it is. A should be the point 0, 1, and it is. And T prime should be the point 3, 1, and it is. So that's looking good. Now we have to reflect over the line x equals 1. But remember, and I didn't write this down, so let me write it down now. X equals blank is a vertical line. And y equals blank, remember, is a horizontal line. So this we're reflecting over this vertical line, x equals 1. So let me get a new pen. I'm going to do this in highlighter, I think. I need to get a color, yellow, for highlighter. So right here is where x is 1. So it's a vertical line, remember, which looks like this, and it's through this point, x equals 1. So I'm going to highlight this so we remember the line that we're reflecting over. And then I'm going to grab a pen and a new color, and we're going to highlight, or we're going to reflect. So look at this. A prime is 1 unit to the left of the yellow line. So A double prime is going to be 1 to the right. And then T prime is 2 units to the right of the yellow line. So T double prime is going to be 2 units to the left. So right here is T double prime. And then finally, B prime is 1, 2, 3 units away from the yellow line. So B double prime is going to be 1, 2, 3 on the right side of the yellow line, B double prime. And then I'm going to connect the dots. And then I just have to write the coordinates. Now it's super important when I'm looking at the coordinates that I remember that that's the origin. So I'm counting from there. So when I look for B prime, B double prime, it looks like we're at the point 4, negative 1. And A double prime is at the point 2, 1. And T double prime is at the point negative 1, 1. Now we can't really do point manipulation this way. I don't think anybody taught it. It's hard with reflecting over a line other than the x or y axis or the line y equals x to use point manipulation. It's just easier to count. Okay, and then I do want to add here, so let me get my yellow pen again, that this is a vertical line and a horizontal line is a straight flat one. Okay, all right, now number 2, get another color. All right, pen, and I want red. Okay, so to do this problem, we have to write all the transformations that map regular K to K triple prime and L to L triple prime and regular M to M triple prime. So to do that, we have to go in order. So we have to go from regular K, which is right here, to K prime, which is right here. So when I'm looking at these two triangles, I'll try to trace them. These two look like that was some sort of rotation of some sort. And let's look at where K was. So K was here in quadrant 1, or sorry, quadrant 4, and it looks like it's in quadrant 3. So that looks to me like we did, this is clockwise, 90 degrees clockwise. So let's just check. The regular K was the point 3, negative 2. And K prime is the point at negative 3, negative 2. Okay, no wonder it looked wrong to me. I made a mistake. I highlighted the wrong triangles, so let's start over with this. So let me just erase everything. Oops. I'll erase that at least. I highlighted the wrong triangle. This was the double prime triangle and not the triple prime, or not the no prime triangle. So let me highlight the right two triangles this time. You probably already noticed that, but these are the two triangles that we're doing. And those, to me, look like a reflection instead of a rotation, which is why the rotation rule didn't work out for us. So again, remember when we're looking for a rotation, or when we're looking at a reflection, we're trying to find the line of reflection. We just find the midpoint between all the prime and the non-prime. So between K and K double prime is this point, between L prime and L prime is this point, and between M prime and M is this point. So that's this line right here, and that looks like it's definitely the y-axis. So we did a reflection in the y-axis. And the book uses the words in the y-axis, and I often use the words over the y-axis. They mean the same thing, but our book actually uses the words in the y-axis. Okay? Okay, so we got that. Now, let me get another color. And I'll do this green. So now we have to go from K prime, so that's this green triangle here. This is the prime one. To K double prime, which is right here, and that's this triangle here. Now that to me looks like a rotation. Okay, So let's try the rotation rule again. This time K prime looks like it's going over there. And again, this would be a counterclockwise rotation. So I'm guessing it's 90 counterclockwise. But we'll just double check. So the point for K prime is -3, -2. And the point for K double prime is 2, -3. And the rule for a 90 counterclockwise rotation is okay, so we are going 90 counterclockwise, and 90 counters AB gets mapped to -BA. So AB, up here, AB gets mapped to -BA. Okay, so I look at my original, and this is K prime, and this is K double prime, and I'm going to see what happened. It's the second coordinate that changes sign, so I'm going to underline it, and then they change places. So when they change places, I write the opposite of the -2, which is +2 first, and then the -3. So that worked. So this is definitely a 90 degrees counter. And you could check all the points, but it is definitely 90 degrees counter. Okay, now we just have to figure out how we get, so let me get a new color pen. How do we get from this one, the K double prime, to the K triple prime? And this looks to me like a translation. And so let's figure out how far we translate it. It looks like we have to go left, whoops, to here, and let's count how many that is. 1, 2, 3, 4, 5, 6, 7. It looks like I went left 7 and up 3. 1, 2, 3. So let's see if all the others are left 7 and up 3. So let's go left 7. 1, 2, 3, 4, 5, 6, 7, and up 3. 1, 2, 3. Yep. And then I could do it with them, but I know that it's going to be left 7, up 3. So how do I write left 7, up 3? Remember, it's XY gets mapped to, and left is X minus, so X minus 7, and up is Y plus, so Y plus 3. So this is a translation, and it's X minus 7, Y plus 3, and XY gets mapped to that. And I forgot to say that this is a rotation. Okay, so the next two problems you have to try on your own. Show it to a math lab teacher, your geometry teacher, or your geometry support teacher. So here's problem number 1, and you try number 2. Good luck.